and he's going to be talking about React is not composable. So let's give it up for him.
Thanks, Luke. Yeah, nice. So, thanks a lot for coming out to listen to me rant. The title is very clickbaity, so it was nice of you to come out for that. In kind of the vein of, say, like a Comedy Central roast, right? We only roast the ones we love. I'm a big fan of React, so I'm going to complain about some things, but if I had to choose it, or if I had to greenfield a new project right now, I would choose React without hesitation. So it's got a lot going for it, and that doesn't mean we can't make it better. So let's start by talking about a short history of React. I'll try and make this brief. So back when it first started, they used to call it the V in MVC, right? Model View Controller, meaning React was just used for that last mile rendering. You would do your application in something else, in JavaScript, whatever else, and you'd hand that off to React, and it would render that to the page for you. And that was really nice because it brought us out of the dark ages of imperative DOM management like we had with jQuery. jQuery was amazing back in the day. We don't need it so much nowadays, but it was really, really useful for smoothing out browser differences. It made JavaScript for the years that it was in play, and it informed what went into JavaScript. Having to, say, go into the DOM and manually move list items up and down was terrible. So with React, one of the big ideas that came out of React was you can take this chunk of DOM, hand it to React, and say, you render it. You figure out the best way to render it to the page. I don't care. I don't want to care. It was kind of a throwback to the old days of server-side rendering, where you just send a chunk of HTML to the browser, and the browser would do it. You didn't have to manually keep track of where a list item was and that kind of a thing. So it was a big deal. And because of that, it had to convince the industry of some kind of odd ideas, right? And some of those things it had to do in order to gain adoption. So one of them was, how on earth could this be performant? So they invented the virtual DOM. Invented is a strong word, but they popularized the virtual DOM. And that was a great way to make this kind of declarative rendering performant. They had to kind of bridge the gap between HTML and JavaScript and a templating language. So they had JSX. They added JSX to React. So it's just another view language. We'll circle back to this. There's no difference between JSX and any of the other templating languages, but they had to make React feel a little bit more palatable to the audience at the time, because they had to answer this question: why doesn't this violate separation of concerns? So for those of you who have not done web development back in the early 2000s, we talked about separation of concerns a lot, all the time. We talked about where it was MVC. Where should my business logic live? How should CSS and HTML and JavaScript all interact so that each one of them is doing very separate jobs, and you can work on them independently. And it was a big deal. We talked about it a lot. And React kind of threw a thumb in the eye of that. So kind of traditional view is HTML is the model, CSS is the view, JavaScript is the controller. Very traditional at this point. But there's really no difference between doing those same three things with JavaScript, right? It's just a syntactical difference. There's no difference. As long as you keep those three things separate, it's just a syntactical difference. And it is important to keep them separate. And React kind of blurred those lines because it was doing more things in JavaScript than we were used to, but those separations are still there, and they're still important. So the guy who created Aurelia had a great breakdown. I've got links in my slides, by the way, so I'll show you the URL at the end if you want to go back through and kind of revisit some of the sources that I've used to put this together. So it's not separating technologies, it's just separation of concerns. It's a syntactical difference. One of the other things that React did is it continued kind of mainstreaming functional ideas in JavaScript, we had Lodash and underscore going back a few years, but React was a big boost in that direction. So being just a V in MVC made React a shoe-in for this idea, which you may have heard come out of some of the more functional React sub-communities or some of the functional compile to JavaScript communities, where your application is a function, a view function applied to your current state. And when the state changes, you run the function again, and you've got a new application. So Dan Abramov, back in 2015, was talking about React's two strengths because it was kind of overshadowed by some of the things that early adopters would get excited about, right? And that declarative rendering was a big one. Anyway, Dan Abramov weighed in on the true strengths in a blog post linked here. It's composition, unidirectional data flow, freedom from DSLs. JSX is kind of a DSL. We can argue about that, I guess. Explicit mutation, and a static mental model. So all very functional leaning ideas. But that left an awful lot of things that React didn't solve, right? Routing, controllers, data stores, data fetching, code organization, app organization, how you configure your development environment, how you keep things sane across a team. So that left an awful lot that React just didn't solve. For example, in 2015, there were Flux variants that came out in force. This is probably not a comprehensive list. So Facebook came out with some suggestions on how to organize an application with their Flux recommendation. People ran with that idea. There wasn't a lot of code attached to that. It was just a recommendation, but people ran with it and created a bunch of ideas like this. Eventually, Redux kind of won out, and it kind of sucked all the oxygen out of that conversation, which was both a good and a bad thing. Most of these are more similar than they are different, and that's not doing anybody any favors. But the end goal was important. So there's a few things that Redux didn't really solve well. That's an ongoing topic we'll circle back to, but it never really had a great async story, still doesn't. The plugins, the additions to Redux that enable async management they have pros and cons, each of them. We'll circle back to it. So, late 2015, the community starts to settle around a few common projects. Those would be React Router, Redux, a few other Webpack certainly, Babel, and React becomes a lot less kind of fragmented. That kind of percolates to the community. Dan Abramov says goodbye to just being the V in MVC in 2016. And React itself is kind of getting new features that are creeping into some of these fields as well. And we'll talk about those and the pros and cons of those as well in a bit. So, so the future of React, maybe, right? Create React apps, certainly popular. React Router, popular. Redux, context, the new context, suspense, all popular, right? Suspense isn't even out yet, and I've seen 3 separate talks on it, just not going looking for it, just happened to be somewhere where somebody was presenting on it. So it might be the future. Let's talk about it. But first, let's talk about composition. Composition is sort of a broad term, vague term maybe. It's got some specific definitions in some communities, but it can mean a lot of things to a lot of different people. Let's start by talking about object-oriented composition. This is, like everything else in the world of object-oriented programming, sort of nebulous, right? It's design patterns, it's suggestions, it's recommendations, it's common things, right? Sometimes you compose objects with mixins. Sometimes you instantiate and manage instances of other classes from within a method inside one class. But in all cases, it's ad hoc, it's manual. You the programmer, do that yourself. You manage all of those instances. You make them all work together. It's on you. There's functional composition. If you've ever used Lodash or underscore, you've probably seen this compose function. It looks like that. That is a lot more specific. The application of one function to the result that you got from another function. So basically just building up a pipeline of computations. It's not as well known, but if you chain map calls together, for example, or then calls on a promise, that's the same thing. You end up with the same result. It's still composition. You're sending the output of one function into the input of the next function. And then, just for the sake of completeness, maybe there's not a formal definition of composition. It's not being used to refer to object-oriented or functional or anything else, but just kind of a general way to say we're going to use two things kind of near each other and make them work together. So, is React object-oriented or functional? Well, we've got classes in React. They do what they do. They hold state and ultimately produce virtual DOM. So they're clearly object-oriented. We also have stateless function components, where it's just a plain old function that React has hidden some wrappers around. But you just write a function that takes some input and produces an output. So it's obviously functional as well. So what kind of composition does React use? Let's go over some of the common things in React that are used for composition. So one, higher order components. You guys may have heard of these, where it is a function that takes a component and returns a new component. Right? So it's as simple as this. You just take an old component in, you wrap it, you can pack new props into it, you can make other changes to it. Sky's the limit. You've got that child function in there that you can do whatever, and then you return that wrapper component and you use that. So hopefully this will be a little analogous if you've ever written a function decorator to just regular old function decoration, where you're wrapping a function and you have an opportunity to do things to the input of that function before you call it. You have an opportunity to do something with the return from that function after you've called it. You have the opportunity to not call it at all, right? We see that with higher order components where maybe you've got a conditional in there saying only render the child component if the user's logged in or something like that. So they're pretty analogous. Yep, function decorator. Maybe even currying, right? A big use case for higher order components is to just pack a whole bunch of new props into some component so you don't have to worry about it. Maybe it's the currently logged in user, the user's selected theme, that kind of a thing. And that's not dissimilar from, say, currying. And a way you would do currying in a language like JavaScript is by decorating it with a function that is going to perform currying for you. So again, if you squint, not dissimilar. In this case, we've got our wrap component here in the middle, and we're just wrapping it 3 times, and we're just packing in new props every time. So useful for a variety of things, adding props, customizing behavior. Brian Lonsdorf, if you're familiar with him, he's a big name in the JavaScript community, has some advice on using closures in general, and they apply to higher order components. So one of the benefits is it's easy to do, right? The wrapping it in another component is not a lot of code, so it's easy to do. Some of the drawbacks are you've packed all of these props into this component, and now this component and all of its children, that kind of a thing, have access to all of the props you've packed in there, whether or not they need them or not. You've got a lot of state that you've packed in there, and there's no getting around that. And you need all of that data up front. You have to have that data to pack it in right when you mount the component. So you can't pull it in, say, lazily or parameterize it. And this makes testing kind of difficult because you need everything to be able to test it. You could pull apart the composition, but it complicates testing. All right, here's another one, render props. Common pattern in the React community, as you guys know, where a render prop is a component that takes a function as a property, and it returns, it calls that function for you inside of its own rendering logic. So that's a nice way to say, have a component that just does business logic, and then pass in a function that is going to render the result of that business logic, and have those two separate. So some benefits there. You get to separate business logic, utility logic, and that kind of a thing from rendering. Those are separate things. Classes are kind of hard to test. We'll harp on this a bit more as we go. So better testability. Some of the drawbacks are the data that you give to that function has to be pre-processed. You want that render prop to do as little as possible. It's going to run inside that render method. You have no control over when that runs, and you want your render method to be fast. So you're going to want to format that data ahead of time before you pass it to this function, because the less this function is doing, the better. The less data this function is doing, working with, the better, right? So for example, you might want to truncate that data. So maybe you're paginating or something. So that render prop only needs the current page. It doesn't need all pages. So performance matters. The person who writes the function has no control over where it's placed, how often it's called. So you just have to write it to be efficient, and if it's not, you have to document the heck out of it, and the people that are using it have to keep that in mind as they're using render props. If you need to pass that render prop down the DOM hierarchy, you're subject to all of the headaches of props tunneling. We'll harp on that again here shortly. And really, render props exist solely to work around this kind of awkward API of having a bunch of stuff locked in a class that's hard to test or hard to compose with other classes. So circle back to that as well. And then if you went to React Rally this last year, somebody was talking about render reducers, which are the same idea as a render prop, but it's a function that you would pass in that would then be called by something downstream that would then change the state of something upstream. So we change the state in the parent, for example. And again, you're separating state management from rendering, which is nice. You've got a pure function, a pure reducer function that you can test. But once again, that reducer function has to be very aware of the performance, how it's used. The person who's calling it has to know exactly how well that's going to perform, so that that person can decide where that person should call it, right? Is this appropriate in a click handler? Probably. Is this appropriate in a scroll handler? Maybe not. It's going to get called a lot more often. Again, documentation. It's on the programmer to know that and figure it out. It's great at managing state. If you've just got flat variables, data that you're managing, it'll do that really well in a testable, pure way. But if you need effects, async, Ajax calls, that kind of a thing, it won't help you there. Again, subject to props tunneling, and again, the reason it exists is there's just no good way to reach inside of a class and pass through this thing that can be composed. All right, let's talk about something a little different for a minute. Let's talk about trees. This is the composite pattern in the Gang of Four book, if you're familiar with that. It's an old Java book about design patterns, some of which are relevant to JavaScript, some of which are not, but it's a good read. So this is, say, a DOM tree, right? We've got the HTML tag at the top, body, head, and then it goes down from there. So maybe we've got container divs. Here's our main content, and here's our header saying who's logged in, and this is another div with a bunch of information about that logged in user, and this is a list of things on the page that leads to an unordered list, and all of these things are list items in the unordered list, and there's spans inside of the unordered list, and buttons, and DOM tree. You guys know this. So one of the things we're going to be talking about is the implications of this kind of a thing in application management, how you're laying things out, how you're passing data around. So let's start by talking about message passing, and state management is kind of related as well. So if you want to do parent-to-child messaging, the way that React handles that, there's other ways to go about it, of course, but the way React handles it is you just rebuild a subset of the tree. You change props, and React rebuilds the subset of the tree for you. React tries to be very efficient about that, so you, the programmer, don't have to deal with it, but at some point, it's good to know that as you're changing props, as you're changing children, React is just rebuilding that subset of the tree. It's going to change as little as possible, of course, but there are limits to what it can know when it's doing that. Child to parent. In the official design pattern for this is event bubbling in the vanilla DOM. So this is the chain of responsibility pattern, meaning an event bubbles up through that tree. At any point, any node can handle it or pass it up or block it from getting passed up. So that's passing a child upstream. And then, of course, there's always the option to just skip the DOM tree entirely and you sideload data. You say, in this part of the tree, arbitrarily, I need to load this data, the currently logged in user, right? The sidebar needs it, the main content doesn't, so I'm just going to put it right where it goes. And the Gang of Four weighs in on this with the flyweight pattern, probably in conjunction with a messaging pattern like PubSub or the observer pattern. But basically, with the flyweight pattern, it doesn't matter as much who your parents are. You don't track it. And part of that is done by externalizing the internal state of a component. So this would be Redux. I put the quote. So one thing to keep in mind is, as you're building up a tree of components, you're not building up the DOM tree. You're building up two separate trees. They're going to be similar, but there's going to be differences. The component tree is used to construct the other tree. And one of the things that's noteworthy here is the component tree can do an awful lot more than the DOM tree can. DOM components do store some state, right? There's a few DOM widgets that keep track of things like the current value or date pickers, that kind of a thing. So there's some light state management, but nothing like we're accustomed to building in React. So that component tree can do a lot more stuff. Arbitrary state, arbitrary other things like iterating over the children and deciding to show them or hide them or delete them or change their props. Sky's the limit there. So it can do quite a bit. And that's relevant because this is not uncommon. I built this. This is my fault. This is a component tree using the React dev tools. It is 81 components deep. There's a bunch of stuff going on in there, expanding, collapsing, drag and drop. I'm not proud, but it's not uncommon, right? This corresponds to this DOM tree here, which is just 21 elements deep. But the difference is of those 81 components, I have to know a lot about what each one of those levels is doing. And let's see, I don't want to spend a ton of time on this, but if you've got this complex tree, 81 components, you're building out something complex, you can put, say you're using component local state. It matters in how you where that state lives matters in how you have to refactor the code if you need to move things around. So say you've got something in here where it's its own universe. You wrote it as self-contained. Maybe it's encapsulating something that open and closes, right? Maybe part of this unordered list, if we're going to call it that, hides and shows depending on whether or not the user has clicked the expand contract button, right? And it's its own self-contained thing. It's fine. Life is good, right up until something else needs to know whether or not that's open or closed, right? Something else on the page needs to animate or show or change some text saying, in reaction to that. And so you change this to accept a prop. Maybe it's a callback. One of the parents passes in a callback, and then the child calls this callback. And this callback is freeform, right? It's not something you can compose. It's its own little thing. The child needs to know how to call it. The parent needs to know to pass it, how to interpret the results. The two need to know a lot about each other, and that's less than ideal in a lot of ways. This is something Redux kind of sidesteps with that flyway pattern we're talking about, where you can just arbitrarily pick a point in the DOM to say, okay, you know about this, and you know about this, and it's fine. But if you're using component local state, then you've got some challenges there. So you do that refactor. So this guy takes a callback that notifies his parent, so his parent can do something with that. And you often find that you have to keep moving that up the tree. If you've ever had to refactor a component where you're moving state up the tree, maybe you have to build a controller component that encapsulates a few of these, because you're doing this with a bunch of components. Every time you make that move, you have to refactor that out and move it up the tree. You have to change the components that are passing the callback. You have to change that signature with every move. The context API isn't gonna, or is specifically designed to help us do this. So we're going to talk a little bit about state management in Redux, but it's noteworthy to point out, while I've got a captive audience and an interlude, that context is specifically designed to just make that process easier. So rather than having to refactor a bunch of components every time you move state up the tree, context says, well, actually allows you to say, actually, I need the state here, I mean here, I mean here, without having to do heavy refactors. But it's not a state management solution. There's a great quote that kind of compares Redux with the context API. And he's being a little tongue-in-cheek, but he's espousing the benefits of Redux. But if he's saying, if all you need to do is pass data around, context is appropriate. If you need to do state management, then maybe it's not. Redux got really popular really fast, and probably to its detriment. A lot of people felt like they had to pull Redux into every little application. And that, I feel like people are moving away from Redux as being too boilerplatey, just too much pomp and ceremony, when they didn't need it to begin with. If you're in a team environment, if you're doing any kind of state management, it's still in play, and don't look to context to help you make that principled. That's sort of the key. Is you can store state anywhere. You can store state on the window object, but you're not going to have a principled way to read and write and debug that, which is the thing that Redux provides. One other thing is suspense. It's interesting, right? It looks really compelling. The API is convenient, but we can do some of the things you can use suspense for right now with good async primitives. If you want an example of that, I presented it at Utah.js a little while back. There's a demo at that link if you're interested. But this is, I mentioned this as part of the interlude because React is becoming less of that V and MVC, and I feel like we're losing some things as part of that. I'll circle back to that. So back to components. Let's talk about props. We're talking about composition, and so part of composing things in React is going to have to involve props, because props are used for component attributes, right? You configure a component by passing props to that component. They're message passing, as we discussed, right? Parent to child by changing those props. Message passing from child to parent via passing that callback function that we discussed. Props are function arguments, right? You need to, say you made an AJAX call and you need to pass that data to the component so it can render it. So function arguments. They're also styles. If you're using CSS and JS, right, you're passing your styles via props. And if you've ever run into a situation where you've got a wrapper component that's got two children and you're passing styles to both of those children, now you need to decide, do I pass all of the styles to both children? What if one style doesn't make sense for one child, but it does for the other child? Or do I need to now bifurcate my style props? So it's like style props for child 1, style props for child 2. That's a non-trivial thing to think about. Maybe you're passing other components with higher order components, as we've seen. Maybe you're passing render functions with render props, as we've seen. Maybe you're passing state management functions with reducer props, as we've seen. So, maybe you're tunneling props through that tree of components because you need to get a prop from this parent to this grandchild, but there's a bunch of things in between, and so those just need to blindly pass through those props. Not composable. There's too much going on there. So let's talk about components. They're often stateful classes, not always, but often. They have a very stateful API. Render is going to be impure. The set state callback could almost be pure if there was just some way to pass the current value, the value that's changing to that callback, because then you'd have a reducer. But neither of these are composable because they rely on that internal state of the class, which means if you want to test either of those, you have to mock out everything else that the class is doing just to get at these two chunks. They require lifecycle methods for the performance tuning that you have to do day to day. Not like the last mile, I need to eke out every little bit of performance from this very specific thing, just like normal stuff, like I got a bunch of data, I've got 5,000 records, and I've got to deal with that, or I've got to make a slow AJAX request, or 3 AJAX requests, kind of a thing. So the lifecycle methods allow you to do that. So it's a nice escape hatch, but it happens so often that it would be nicer if you didn't have to rely on lifecycle methods for that, and there was just a way to say, hey, this specific thing changed. This is a link to a YouTube video that goes into that in detail, and has some pretty compelling ideas. They are highly coupled to where they live in that component tree, right? Again, that's the problem the context is looking to try and solve, but where you put it in the component tree matters when you have to refactor, when you have to use it with other things. They encapsulate an awful lot of things in that class. You've got state, business logic, data fetching, effects, side effects, and then that ultimate view that you're rendering. And every single one of those things composes. They do. But every single one of those things composes different than the other things. You can compose state together. You can compose business logic together. Right? We know how to compose functions. We know how to compose data structures. We know how to compose promises. But in order to do that within the context of a component, we have to pull it out somehow. Again, not composable. So closing thoughts. Let's not end on a negative. We're still figuring out how to make UIs as an industry. The computing industry is really young, ridiculously young, embarrassingly young. We've been around for 60 years, give or take, and we're not always great about relearning lessons of the past or learning from lessons of the past. We have to relearn them the hard way, it seems. We rewrite our apps all the time for every new framework that comes out. We work on a code base for 2 years and then nobody wants to work on it anymore. It's unmaintainable. It's awful. So we need people to care, to keep discussing patterns, design patterns, what works, what doesn't work, in a really objective way. We need people to be interested in it. We need, as an industry, we need to focus on programming fundamentals and techniques. That means reading books. That means really learning JavaScript. Not a framework, not the way the framework does it, but the JavaScript fundamentals so that you can appreciate how the framework applies those fundamentals or doesn't, right? If it doesn't, you can completely sidestep that framework and say, well, actually, I know a better way to do this. And to be wary of the new framework that comes out all of the time, because they do. I won't read the whole thing. This is a wonderful podcast. It's 2 episodes. They're pitching a state management library, which also looks kind of compelling. But the fun part of these 2 episodes is they go into the history of state management in the front end. They go into the history of state management in React, and they kind of compare and contrast the different techniques. And so it's a fun listen just for that, the Frontside podcast. They're talking about a library called microstates, which is worth looking up on its own. That might help you find this podcast as well. But he has this great quote where we as humans kind of like tribalism, right? We like to root for our team. And he makes the point that he thinks that some framework authors kind of milk that on purpose to drive interest in the framework. So as far as conspiracy theories go, it's a fun one. People are interested in exploring composition. These are interesting talks to have with your teams. You send in a pull request. If you've got people on your team that are interested in talking about these, great. If you don't, there's a lot of people online that love talking about this. But sometimes you gotta go looking. If you were at React Rally in 2016, Brian Lonsdorf gave a wonderful talk called "Oh Composable World." And as you may have noticed by now, we're kind of wrapping this talk up, and I haven't presented any solutions. And that's not an accident. I would like to talk about those solutions. I've got some ideas of my own. I don't know if they're right, I don't know if they're wrong, but I do know that all of us together having a conversation are smarter than just one of us trying to figure it out. And he's got some compelling ideas in this talk, which are well worth talking about, that say this is how you differentiate the input of a component from the output of a component. And so now, poof, with that one addition, suddenly you can compose props together. You can compose the output together. And it just blows the doors wide open for those 2 bits of composition. We've got a big list of other things to compose, of course. But that one change, basically it's just a method you would call on a component. In this one, he calls it contra map. And there's a lot of computer science and math and kind of theory behind where that comes from. But in short, it just lets you compose 2 functions that deal with props together, like you would compose any functions. And then call the component with the result. And the same goes for the output. So you've got JSX as output, you've got other JSX as output. You can then compose them together by, say, wrapping one on the other or appending one to the other. And bang, composable. Another one, we need composable async first state management. Async is everything that we do. It's to our detriment to kind of shy away from it and say it's hard and try and avoid it. One of Redux's great kind of omissions is not baking in async to as a first class thing to what is really elegant state management. But everything we do is async. All of the AJAX calls, all of the WebSockets, all of the event handlers, all of the set timeouts, everything we do is async, and we need good solutions to that. If you haven't played around with ReactJS, I'm a huge fan. It solves this problem wonderfully, but so do other things. We need good message passing primitives. Props are not that. Props and callbacks are definitely not that. So we need good ways to get messages to and from parents and children in the tree. Maybe that's stepping outside the DOM tree and hooking in some other messaging library. Again, RX is pretty good at that. Or maybe it's just making other improvements. Maybe it's a different method like contra map that is specific for message passing in that tree. So, whenever you're evaluating a new framework or library, ask yourselves a few questions. Does the library espouse a new idea or technique, or is it a rehash of something you've already seen? If it's a rehash of something you've already seen, it's got to be really compelling, right? There have to have been some significant pain points. It can't just be the difference between chocolate and vanilla. It has to be something substantial because there's an awful lot of these, and our time and lives on this world are finite. Ask yourself what the author's motivations are. Sometimes people will throw libraries out there just to make a name for themselves. They are not interested in maintaining it. They just want to hit Hacker News and call it a day, cash in the internet points. Ask yourself if they use React in their day job, right? That's a nice kind of differentiator. There's a lot of trainings and videos and blog posts and Medium posts, and some of them are really good, and some of them are not. But if the person who wrote it is not using React day in, day out, I'm kind of suspicious as to how deep their insight really goes. Watch out for hero worship. People that work for the big tech companies, they're regular schmoes like us. Meet them, talk to them, meet them at a conference, buy a beer, and you'll find that they're just regular people. They make mistakes just like the rest of us do. If you need any evidence of that whatsoever, take a look at the entire Angular 1 debacle, right? It came out of nowhere, took over for everything, and then they just abandoned it for Angular 2. They realized that there were some significant mistakes there. So much so that because they worked for Google, they were able to put some of those ideas on a standards track to make it into JavaScript, which then also were abandoned. That was the object.observe proposal. So, and it was a cool proposal. I was excited about it when it came out. It just didn't work out long term. So they make mistakes. They're just people. You can do what they can do, right? Maybe they read more than you do. Certainly I do, right? But they're just people. So if you're interested in that, if you want to do it, you can do it. And then keep an eye out for things like bike shedding and personal preference. The goal is to be able to maintain a code base over time. That's the hardest thing we do, is making sure that you write something and then 2 years later it's not awful and it still works and you can still expand it. That is really, really hard. That's the holy grail of what we're trying to accomplish. We can't just write something and then change jobs every 2 years when the thing that we wrote turns out to be awful and we don't want to work on it anymore. We as an industry have to get better at doing that. I really think that if we don't, then we're going to be hit with regulation. Our software is not good enough. It's not secure enough. It's not maintainable enough. And if we don't fix it, government or whoever else will come in and kind of force our hand. Because why should a business pay to rewrite their front-end framework every 2 years? It doesn't make sense for the business. The end users don't care. So there's this great quote from a professor that software engineering is still an aspiration because computer science is not yet a science. And it's meant tongue-in-cheek, but her point is that we don't apply the scientific method to the kinds of things that we're doing as often as we should. There's some things we can't, right? How do you apply the scientific method to MVC versus MVVM, right? Eventually it's going to come down to personal preference, but sometimes it won't. And measuring real things, measuring how software can be maintained is important for us as an industry. So, all right, in closing, not everything should be a component. A component is indirection. You have to know a lot about what that component's going to do because it can do anything to its input, its output, its children, side effects. You need to know what it does when you pull it in. So only use as many of them as you need. Write regular JavaScript where you can. And it turns out you can do that a lot more often than you think. There's a lot of these patterns that just work in regular JavaScript that you don't need to encapsulate in a component. You don't need to wrap it in the syntax of JSX. It's fine as it is, and you can pull it in to React in JSX and use it from there. So, they're useful, but in moderation. Thank you. The question is, where is the trend kind of stemming from in the React community where encapsulating everything in a component is becoming kind of a popular thing? I think it's because, to your point, it is clever, right? It's a cool hack. It's like something new. I hadn't seen that before. It's cool, but if you strip away the JSX, if you strip away the DOM tree, what you're left with is function decoration, right? And that is a lot more approachable in its on its own, outside of React, outside of JSX, And so if you can get away with the simpler approach, I think it's better, right? We're still kind of enamored. We're still kind of in love with React and kind of what it's given us, and that's non-trivial stuff. But that doesn't mean we should use it everywhere. It doesn't mean that it's appropriate for everything.
One other question I have is, and maybe you touched on this a little bit, but why do you think, I agree with you, you kind of said there's a lot of async solutions in Redux, and most of them are not very good. And I agree with you, I've used several, and it always feels like there should be something better. So what do you think is the challenge there?
Yeah. The question is, there's an awful lot of solutions in Redux for handling async. Why is that, and what's compelling in there? So Redux Thunk is sort of like the most simple thing you can do, which is it's a function that runs at some later point, right? You pass a function, the thing that you pass the function to calls that function when it's ready to call the function and deal with whatever that function does. And that's simple. It's appealing because it's simple, but it's also limited because that is not a function that can be composed with other functions. That's something that's effectful, and that makes composing it really difficult. So whenever you have to do anything complex with that, then your hands are tied, and that includes testing. So that's where Redux Thunk kind of falls down. Redux Saga is sort of a slight improvement over that. Testability is still difficult. Where promises are not good enough. We've got promises. This is a whole other topic, which I've got up as well if you're interested. But the short recap of that is promises are kind of a terrible async primitive. Since they're eager, they're not composable, and since they auto-flatten, it kind of limits how you can use them together. So like you can't make a promise of promises, for example, and sometimes you really want to do that. But promises are nice that they're baked into the language, but if you've never used JavaScript before promises were added to the language, there's nothing magical about them. They're just syntactic sugar around callbacks. Async await is just syntactic sugar around promises. So if you're hoping that like async await will save us, it's got all of the limitations that promises do. And promises are just a little sugar around callbacks. And so are observables in, say, ReactJS. The difference is ReactJS comes out of a branch of mathematics that is completely focused on composition. It's a branch of mathematics that says, how do things relate with other things? And so ReactJS, for example, is composable to the nth degree. So Redux is best, to answer your question finally, Redux's best contender at the moment is probably Redux Observable, or what's it called? Redux Observable. But it's still limited because you can only use observables within the context of while an effect is happening. And it gives you a lot of control over that effect, and it lets you compose that effect with other effects really easily, and the testing story is amazing. But you can't use that composition or that async first class anywhere else in your application except for where that effect is. And Rx can go so much farther than that. But yeah, async primitives, bad async primitives, really kind of are the answer to that question. We need things that are better than promises because they don't compose. Any other questions? If not, I love chatting about this stuff. Grab me afterward. Thanks.
Cool, that was an awesome talk. I don't have anything else to say. Well, I do have a couple things to say, I guess. Thank you guys all so much for coming.